Ladies and gentlemen, please welcome Dr. Stephen Meyer.
Thank you, Mark. How are we doing on the sound? Not too loud, not too soft? Okay. I've been incredibly well welcomed here today. I am so impressed with your founders and with your administrators and your teachers and the students that I've met, and it's just been kind of a rush. I'm on a little bit of a high today. So it's nice to be able to come back this evening and share with a wider group of people. I'll be talking about my book tonight. I'm going to try to keep the talk, it's a big subject, and I typically go about a full hour, but we're going to leave some time after that for Q&A, and so I just want to let you kind of in on the structure, because I really want to have the conversation afterwards and field questions and points of deliberate about some of the different issues that are raised in the talk. Just one word about the Q&A. When I was in grad school, my first year, I'd come from a little college, as Mark had mentioned, Whitworth, which is in Spokane, Washington. And when I got to England, and everyone spoke so beautifully, and they sounded at least 20 points higher in IQ than any of us Americans because of that lovely British accent. And it was all a little bit intimidating, and all the other people in my department were from very impressive places. So, and then one day there was an expert scholar who came in who was an expert on the philosopher Kant, and he gave a really amazing lecture about the works of Immanuel Kant, the German philosopher. And even though I had studied physics and some more science things, I had taken one philosophy class on Kant's work, but the things that the scholar was talking about, I had never heard about. They were his philosophy of beauty, and I'd studied more of his philosophy of science. So I, at a certain point in the lecture, I raised my hand and said, I've never read any of those the sources you were mentioning of Kant's works on aesthetics. Would you mind recommending a good place for me to start? And there was this kind of uncomfortable shuffling in the room, and this visiting scholar gave me a recommendation, and I had this vague sense I might have done something not quite, not the done thing, as the English said. And so anyway, afterwards, my supervisor took me aside. He was a don of the old school, and he said, Meyer, he said, in the States you've learned that the only stupid question is the one you didn't ask. He said, it's different here. And he went on to say, if you, in the future, if you have a question that reveals ignorance, he said, please come ask me privately. He said, everyone is bluffing here, and if you're to succeed, you must learn to bluff too. So anyway, we will have some time for Q&A afterwards, and I just wanted to assure you it will be American rules, okay? No stupid questions. Okay, so I want to talk tonight about my book called Darwin's Doubt, and it tells a story. It also makes an argument. And the book begins with a line, and I'll quote it. It's always kind of vain to quote yourself, but it's a... what am I?
For photo ops.
Oh, am I? Oh, my gosh. I took the jacket off, and now I'm all messed up. Oh, just beautiful. Oh, my wife's going to be scandalized. Okay. She'll say, I sent you out the door looking properly, and now look what happened. Okay, so anyway, the book Darwin's Doubt tells the story, and it tells the story of a doubt that Darwin had about his own theory, and how that doubt has grown up to create a major crisis in evolutionary biology today. That's what the book is about. And I start the book with a line, and I'm going to quote myself. It's a little bit self-aggrandizing, but forgive me. When Charles Darwin finished his great masterpiece, The Origin of Species, he thought he had explained every clue but one. And the one clue he knew he hadn't explained, and now I'm going to see if this system we have for advancing the slides, we did, okay. The one clue he knew he hadn't explained was an event in the history of life known as the Cambrian Explosion. And the Cambrian Explosion refers to the geologically sudden appearance of most of the major animal groups or body plans. And in the way that biologists classify animals, they have a hierarchy of classification. And the biggest group, the phyla, correspond to many different types of animals that exemplify the same body plan, where a body plan is kind of an architecture. It's a unique arrangement of body parts and tissues. So some familiar examples might be chordates, which have an internal spinal column or notochord. And the body logic is built around an internal structure. Another distinct body plan would be things like arthropods. And we've got lots of them running around, insects, crabs, and in ancient times we had these things that fascinated me called trilobites, and they have a hard exoskeleton. So it's a completely different architecture and logic built around a hard external skeleton. And many of the major body plans that have ever existed on Earth emerged very suddenly and abruptly in the fossil record in the same period known as the Cambrian period. And Darwin was aware of this in 1859, and it troubled him because the pattern of appearance didn't really match what he had described in his book, or he had depicted the history of life as a great branching tree, and yet the fossil evidence seemed to suggest that the first animals arose very abruptly with no discernible ancestors in the lower strata that would allow the scientists to connect the dots and form a tree-like picture of the history of life. So this is a diagram. Uh-oh, how far have I gotten? I'm pressing buttons up here and not, sorry. We have an interesting system. My computer isn't hooked up to what's actually going on back there, so sorry about this. Here's a nice picture, by the way, that depicts the challenge of the Cambrian explosion. You see all these different animal forms behind me. On one side, you see the sedimentary rock column, and on the other side, you see the standard geological dating scheme in millions of years. And you see that at a particular point in the history of life, boom, you have these new forms of animal life that arise very suddenly. And as I mentioned, this contradicts the Darwinian picture of the history of life. This was part of his theory, was the idea of universal common ancestry. And he depicted that idea with a branching tree where the forms at the bottom of the tree represented the first very simple, probably one-celled organisms. The branches at the top represented all the complex forms of plants and animals we see today. And then the intermediate, the connecting branches represented what are called transitional intermediates or ancestral precursor forms. Now, the challenge of the Cambrian is represented by this part of the branching tree, which shows the first animals arising. They're represented by the gold dots at the top, but the blue dots represent the expected precursors that the geologists and paleontologists and evolutionary biologists expected to see in the lower strata. And you can see the problem is that these discernible ancestors have just not turned up. The blue dots represent things that should be there and aren't there. The gold dots represent what's actually there. And so what we see in the history of life is something that looks more like a lawn or perhaps an orchard of separate trees, not one big branching tree that connects up at the base with that first primordial form of life. Okay? And so there's a contrast, a tension between the theory and the data, the theory and the evidence. Okay? Sorry to keep turning around. I just want to make sure that what I'm showing you is what I think I'm telling you about. Okay. So that's the challenge. And that was the problem. The doubt that Darwin had, not about whether his theory was true. He was pretty convinced he'd gotten it right. But he had a doubt about whether his theory could explain all the relevant evidence, and he was worried about it. And this problem, this tension between the data and the theory, and the absence of those ancestral precursor forms leading up to the first complex animals, I call the mystery of the missing fossils. And this is, the first third of my book is devoted to discussing this mystery. And here's what Darwin said about it. He said, to the question why we do not find rich fossiliferous deposits belonging to these assumed earliest periods, prior to the Cambrian system, the Cambrian strata, I can give no satisfactory answer. This is right in the Origin of Species. Now, it's really interesting. I really appreciate Darwin because, unlike many of his modern defenders, he was rhetorically honest. He was rhetorically modest. He didn't try to say he'd solved all the problems when he hadn't. He didn't pound his fist and say anyone who disagreed with him was stupid or ignorant or insane. But some of his modern proponents do say things like that. A few years ago, I had the chance to testify before the Texas State Board of Education. And they were looking at enacting a policy provision that would encourage teachers to teach the strengths and the weaknesses of competing scientific theories. And the Darwin-only science lobby turned out in force to argue against this seemingly common sense provision. And their argument was, and I quote, "There are no weaknesses in the theory of evolution." Let me get it up there. There we go. And this is Eugenie Scott, who was then the president of the National Center for Science Education, a small Darwin-only science lobbying group out of Oakland, California. And when I saw this, I thought this was an incredibly unfortunate statement. I was about to present into evidence a binder of 100 peer-reviewed scientific articles questioning various aspects of contemporary evolutionary theory, what's known as neo-Darwinism, the standard textbook theory that we all learn in our high school and college biology texts. So at the very least, there are scientific problems with the theory, scientific weaknesses of the theory that need to be explored. Darwin was aware of some in his time and talked about them openly, but unfortunately in our modern discussion of biological origins, too many people defending the orthodox view think that they can't acknowledge the actual state of the science that is in play. One of the worst offenders in this regard is the well-known evolutionary biologist and new atheist named Richard Dawkins from Oxford University. He's actually said it's absolutely safe to say that if you meet somebody who claims not to believe in evolution, that person is ignorant, stupid, or insane. And then he said, in parentheses, or wicked, but I'd rather not consider that. And I thought that was really sporting of him not to consider that maybe the people who disagreed with him were wicked. That's not rhetorical modesty. That's rhetorical excess. And there's an awful lot of it in this debate. And so I do appreciate that Darwin was so honest about the things that he could and the things that he couldn't explain. So his statement here, the evidence from the Cambrian Explosion at present must remain inexplicable and may be truly urged as a valid argument against the views here entertained. So that's what I call the mystery of the missing fossils. And it haunted Darwin to his death, but he did have, he was a smart guy, and he had an idea about how this could be resolved. He thought that, let's see, I'm coordinating my forces here. Okay, mystery of the missing fossils, ta-da. He thought that the absence of these ancestral intermediate forms would be eventually explained away by future fossil discoveries, which is to say that the missing forms would actually turn up if we kept looking hard enough in the pre-Cambrian strata around the world. So he had this charming analogy to a book, that the fossil record was like he said, I look at the natural geological record as a history of the world, imperfectly kept. And on this view, the difficulties discussed above about the Cambrian explosion are greatly diminished. So he said, imagine that the fossil record is kind of like a book, and it's recording some of the layers are there. They're like a chapter, but then other chapters here and there are missing, and some chapters we may only have one page. And eventually, if we find the other pages and the other chapters, then it will show this seamless, gradual, continuous, changing progression described by his history of life depiction of the origin of all the new forms of life on Earth. So that was his hope. And this idea became known later as the artifact hypothesis. The idea there is that the absence of those fossils in the lower pre-Cambrian layers are an artifact or a byproduct of our incomplete sampling of the fossil record. We just haven't looked hard enough. And another version of that same idea, well, a slightly different version, but the same kind of concept, was that the missing ancestors are an artifact of incomplete preservation. Maybe there was something in those sedimentary, the sediments that were in the Precambrian that were just not capable of preserving those ancestors. Maybe they were too small. Maybe they were too soft to have been fossilized. So that was another idea. So either it was an artifact of incomplete sampling, inadequate sampling, or incomplete preservation. And that idea became kind of the go-to explanation as to why these fossils were missing. Now, unfortunately, for the defenders of Darwin's theory, additional fossil finds have not actually resolved the mystery of the missing fossils. They've actually made the mystery more acute. In Darwin's time, there were there were several main forms of animals that were known. There were these trilobites, which fascinated me as a kid. They look kind of like potato bugs, if you've watched those guys. But I forgot, I have a really nice sample of one that has a compound, you can see the structure of the compound eye in the fossil that I have. And it's just, you realize that it was a very sophisticated visual apparatus from the very beginning, from the dawn of animal life. It's extraordinary how complex these animals were. And Darwin knew about these guys. He also knew about other animals called brachiopods and several others. There were several main groups. But in 1909, there was a huge fossil find. Do I have a picture of Canada behind me? Okay, thank you. I didn't want to keep turning around. How interesting can the back of my head be, right? And right near the border between British Columbia and Alberta, in a place near Field, BC. And these fossils were discovered by a paleontologist named Charles Walcott. And Walcott was prospecting for fossils. It was near the end of the 1909 prospecting season. The weather was getting bad. His horse, or it may have been a mule, slipped on the path. His wife was on it. She wanted to get the heck home to Washington, D.C., and the legs of the horse went into this talus slope of loose hunks of shale. And as they pulled the horse out, he flipped one over, and it revealed an amazing, delicate lace crab, an animal that had been previously unknown and unknown to this period of time. And you can imagine the winter that Walcott had waiting to go back to see what other treasures lay in these hunks of shale, which later became known as the Burgess Shale. And he did, in fact, go back, and the Burgess Shale revealed, this is an artist's depiction of that lace crab, and he went back, and it was a trove of new animal forms. Here's another guy called Waptia. You see the beautifully segmented, articulated exoskeleton there. It looks like a shrimp with a hard head shield. Here's a picture of another fossil of this guy from another locale with a beautiful artist's rendition. But you can see that, there were just all kinds of interesting, this guy's called an opabinia. He has 5 eyes, a long proboscis, and I think it's about 30 segmented body segments. Stephen Jay Gould, the famous Harvard paleontologist, wrote a book called Wonderful Life, all about these extraordinary animals that were discovered in the Burgess Shale. So whereas before we had a few basic forms of animal life that we knew had arisen, or that the paleontologists in Darwin's time knew had arisen in a really discrete and abrupt way, now as a result of the Burgess Shale, there was, and I'm showing a bunch of, this is a guy called Wewaxia. All these are animals. This guy kind of scooted around the bottom. Now, as a result of the Burgess Shale discoveries, there are loads more animal forms whose first appearance is documented in the Cambrian period, and each of whom lack ancestral precursors in the lower Precambrian strata. So now, from our vantage point, we've discovered that the Cambrian explosion was much more explosive than it was understood to be in Darwin's time. The mystery of the missing fossils wasn't attenuated or mitigated by fossil finds. It was accentuated. It was made more acute. So that, these guys, these are the morellas there. This is what some of the paleontologists think that this little lace crab is called Morella splendens. So beautiful. So I've got this animation. It goes on. You can see more of this on my website. So anyway, that was one big fossil find. And did we skip on to, we're still animating here. Let's see if I can get that's back to, okay, now this is the next big fossil find. 1984 in southern China. There's another huge Cambrian discovery. And it was very exciting. In the 1990s, they ended up doing a cover story on it in Time magazine with the title, Evolution's Big Bang. And one of the paleontologists who was commenting on this find It was extraordinary for a number of reasons. The preservation was even more exquisite than the fossils at the Burgess Shale. There were more new animals discovered than had been known even from the Burgess find, so the explosion again looked more explosive, more new forms of animal life, again each lacking those ancestral intermediates. And the time period in which geologists estimated these events to have occurred shrunk quite dramatically. And so one of the paleontologists quoted in this article said, well, what I like to ask my evolutionary biologist friends is this: how much faster does this event have to get before we stop calling it evolution? It's really abrupt, okay? So this accentuated the mystery. And in the year 2000, we had a chance to host one of these Chinese paleontologists who made these discoveries at the Discovery Institute. Well, actually, we hosted him to give a lecture at the University of Washington. And the University of Washington in Seattle, big research university, and word got out that J.Y. Chen was coming, the Chinese Stephen Jay Gould, the Chinese Simon Conway Morris, a big player in this field worldwide. And the word got out that he was bringing fossil samples from the Chengjiang locale, and this was pretty exciting. So there was a good turnout, and Chen walked us through many of the amazing creatures that had been discovered. This is a guy called Anomalocaris. He was the top of the food chain predator in the Cambrian seas, about 1 meter long, extraordinary, and the preservation of the body parts and tissues. It was another arthropod, extraordinary creature. Another animal that was discovered representing the phylum Hyolitha. This hyolith was an animal that lived inside a conical shell that had an attached lid that opened and shut. Another interesting body plan. Different kinds of worms, a phoronidid worm that had a feeding organ and a thing called a lophophore, a worm inside a tube. The worm lived inside the tube. But then another kind of worm, an annelid worm that was segmented and had lateral bristles for locomotion. So lots of distinct body plans and architectures exemplified by these different animals. This guy I really like. It looks kind of like a plant, but the more they studied it, the more convinced they were, the paleontologists, that it was an animal. But the organization of this animal, called Deinamiscus, was so unusual, they didn't quite know how to classify it, so they just called it a problematica. You can see, ladies and gentlemen, how science works. Okay, so that was kind of neat. So we were getting a really good fossil show. Oh, and this guy's my favorite, because we have these in the Puget Sound where I live, near Seattle. And this is extraordinary. This is a comb jelly. And you can see, let's see, the picture on the left is a photograph of a modern translucent comb jelly. And the picture on the right is the artist's depiction of what's being shown by that Cambrian era fossil. So on the standard geological timescale, this guy's been around for 520 to 30 million years, and he hasn't evolved at all. This is a phenomenon that paleontologists now call stasis, which is a lack of directional evolutionary change. Things just stay the same for a long period of time, kind of mysterious on a Darwinian point of view. In any case, Professor Chen talked about all these different forms, and then at a certain point in his lecture, this came later, this was discovered in 2009, we learned that the first fishes actually arose in the Cambrian as well, which made the explosion, again, even more explosive. But in this talk in 2000, Professor Chen was talking about these different forms of life, and at a certain point in his talk, he said, you know what's extraordinary about these fossil forms, and he held up his hand like this, and he said, is they turn Darwin's tree of life upside down. So now in the Darwinian tree of life, the little changes accumulate over long periods of time, eventually resulting in big disparities in form. A chordate is really different than an arthropod. That's a completely different body organization. Theoretically, from a Darwinian point of view, those two forms of animal life would have had a common ancestor way, way, way back. So it takes a long time to develop those big differences, and they only arise at the end of a long process of gradual evolutionary change in the Darwinian theoretical perspective. But Professor Chen pointed out those big differences in form were present right from the very beginning. Echinoderms are different than arthropods, are different than chordates, are different than comb jellies. Okay? Really, and they're all very different. And those differences are present from the beginning. So he says it turns Darwin's tree of life upside down. So that was a really interesting comment he made. And then there was a Q&A afterwards. And one of the University of Washington professors, at a certain point, raised his hand. He said, "That was a fascinating lecture. Thank you for coming to our country. Thank you for coming to our university. Your fossils were wonderful." But he said, "I do have one question for you. Aren't you a little uneasy about expressing skepticism about Darwinism coming as you do from such an authoritarian country?" It got very quiet in the room. This was really an insult to China, and Professor Chen didn't miss a beat. He smiled and he said, "No," he said, "in China we can question Darwinism, just not the government. In the United States," he said, "you can question the government, but you can't question Darwinism." And he had heard about our political correctness in our universities, and had a kind of a message for us, which is, whose country is more free, really? We're able to discuss these things in my country, he said. So that was kind of interesting. I love this guy. This is one of the earliest fishes ever discovered in the Cambrian, right from the very beginning. Now, even as ardent an advocate of evolutionary orthodoxy as Richard Dawkins has acknowledged that the Cambrian explosion represents a bit of a puzzle. He says it's as though the animal phyla, the new animal forms, were just planted there without any evolutionary history. That's what it looks like from the fossil record. Of course, he says we know that's not true. There must have been these forms in the earlier record, but it's as though they were just planted there. Now, he is expressing a commitment to this artifact hypothesis idea that they must be missing because they're by the time 1984 and the 1990s and right up to the present, there are very few paleontologists who any longer think we haven't looked hard enough for the ancestors in the Precambrian. But up until relatively recently, there were still a lot of people who thought, well, maybe we're missing the ancestors simply because they weren't preserved. And the most popular version of the artifact hypothesis was that they weren't preserved because the ancestors were too small or too soft. But the Chinese fossils revealed something relevant to that claim as well. And that was a really interesting find in a layer of rock just beneath the layers that document the Cambrian explosion. This is a layer called the Dushantu Shale. And in this shale, it's a very late Precambrian sedimentary layer. The Chinese paleontologists have discovered little tiny microscopic fossils going through the first few cell divisions. They're embryos, probably of sponges, a very simple animal form, one of the few animal forms that originated in the late Precambrian. Now, this discovery raises a huge problem. It produces for the artifact hypothesis. And it's this: if the late Precambrian sediments are capable of preserving small microscopic fossils, why didn't they preserve the ancestors to all the other animals that first arise in the Cambrian? The fishes, the trilobites, the animalocarids, all these other guys. Especially since most of them would have had to have some, at least, hard parts, because they're animals with hard exo or internal skeletons. If you can preserve an embryo, a soft tissued embryo at that, why can't you preserve all the other ancestors? So now I would say the dominant view in Cambrian paleontology, especially among the leading experts on the explosion, is that the explosion is real. It's not an artifact of incomplete sampling or an incomplete fossil record. There was a very important book on the Cambrian explosion that came out in 2013, the same year as mine, by James Valentine and Doug Irwin. And they basically, there's no friend of my preferred perspective, which I'll explain later, but they very much think that the Cambrian event was real, and whatever we make of it, they argue, we've got to reckon on the explosion as being something that really happened. It's not just an artifact of incomplete sampling or incomplete preservation. Now that's the first mystery that I address in the book. The second one has to do with what you really can think of as, first of all, it's a deeper problem, and it's an engineering problem. It's the question of how would the evolutionary process build all this new form and structure, especially in such a short period of time, geologically speaking and biologically speaking. The natural selection random mutation mechanism needs a long time to work. And scientists can actually, there's a branch of evolutionary biology that allows scientists to actually calculate what are called waiting times. If you know the size of a population, the mutation rate, the time from one generation to the next, factors like that, you can calculate for any given series of mutations how long you should have to expect for such an event to take place. And as those calculations are being made, if you get beyond 2 or 3 coordinated mutations, the waiting times just balloon well beyond the time available for the entire history of life on Earth, excepting the great ages that most geologists talk about. So give them 3.5 billion years. It's not enough time to generate the kind of changes that we see in the history of life using the mutation natural selection mechanism. So that's a big problem. Now, in my book, I discuss this problem in light of another discovery that makes the problem even more acute. And that is the discovery of the information-bearing properties of the DNA molecule. This discovery came in the 1950s. Watson and Crick, I'm not pressing the right buttons up here, thank you. Watson and Crick elucidate the structure of DNA in 1953. The structure, they realized right from the beginning, suggests that the DNA molecule may have the capacity to store information in a digital form. In 1957, Francis Crick proposes something called the sequence hypothesis, in which he suggests that the chemical subunits along the interior of the DNA molecule are functioning like alphabetic characters in a written language or digital characters in a section of machine code, the zeros and ones in a section of software. Which is to say, it's not the chemical properties of these chemical subunits in DNA that matter. It's not the shape of those subunits. It's their arrangement in accord with a symbol convention or code that allow them to convey instructions for building all the important proteins and protein parts that cells have that keep them alive. I'm competing with myself here. Okay. So I've got a little piece of animation that I'll just run in the background as I'm describing this, but this has been one of the great discoveries of modern biology. It's a stop-press moment in the history of life. The biologists discover that code is literally running the show inside living systems. Let me give you an analogy, and as you can see some of the animation running in the background, it's explaining how, and you can watch this on my website if you're really interested tonight, but the animation is explaining how the digital information in the DNA molecule directs the construction of the protein parts that are so important to keep our cells alive. Proteins perform all the important jobs. They catalyze reactions. They form the structural parts of molecular machines. We have inside cells extraordinary little tiny nanomachines, rotary engines, sliding clamps, turbines. It's just extraordinary. They're typically made of proteins, and the proteins also process information. So you've got this extraordinary process going on inside the cell, and here's the analogy. Any engineers here in the audience? Okay, some engineers. Familiar with CAD/CAM, computer-assisted design and engineering? I'm from Seattle. We've got 2 really famous companies up there, Microsoft, where they write code, Boeing, where they use code to direct the construction of mechanical systems called airplanes. So you've got an engineer sitting at a console. He writes code to specs for producing a particular part. That code is sent down a wire. It's translated into a machine language that can be read at the manufacturing center, and then that manufacturing center will take that information and use it to, say, place rivets on exactly the right place in the airplane wing. So you build the airplane wing according to specs. Information directing the construction of mechanical systems. That's what's going on inside cells. Molecular machines made of proteins. The proteins are built according to the specs, the instructions stored in the DNA molecule. It's a mind-blowing discovery. Now, I call this discovery the DNA enigma. And the enigma here is not, sorry, let's go. Yeah, there we go. It's not what the DNA does. It's not even the structure of the DNA molecule. Watson and Crick solved that for us. The information is, the enigma is, where did the information come from? Okay? And I found in talking to students, nobody talks about that in biology classes. They say, here's what DNA is, here's the structure, here's what it does, but no one raises this deeper question, where did it come from? Now, I also used to ask my students the question, if you want to give your computer a new function, what do you have to give it? Software. I heard instructions over here. Any other answers? Code. Okay. Check, check, check. All right answers. So the same thing turns out to be true in life. If you want to build a trilobite from whatever simpler form of life was around before, you've got to generate a whole new group of specialized cells. Every new cell type needs dedicated proteins. If you're a gut cell, for example, if you have a gut in an animal, those cells need enzymes, digestive enzymes to do their job. And those proteins are constructed in accord with the instructions stored on that DNA molecule. So what's this all got to do with the Cambrian explosion? Well, when we see all these new forms of animal life, we're not just looking at an explosion of new form, of biological form, we're looking at a new explosion, we're looking at an explosion of new information. And that's the big question that my book addresses. Where does that information come from? Now, there are many reasons that the neo-Darwinian mechanism, the idea of natural selection acting on random mutations, does not explain the origin of that information. Let me run one by you, it's just a little bit intuitive. If you, software programmers, engineers here, if you've got a section of software and it's functional, maybe it's a whole program, and you start changing the zeros and ones in that software randomly, question, are you more likely to degrade the information that's present there already, or to generate a whole new software program or operating system? The laughter shows that everyone gets the point, right? When my daughter was in middle school, she was on a soccer team called the Polar Bears. And she had a real gruff coach with a shaved head, and he kind of intimidated me. Turns out, though, he was a really smart guy. He was an architect-level programmer at Microsoft, and I didn't know he knew anything about what I did. And one day, we're watching the girls play, and he saunters over on the sidelines and leans over to me like this, and he says, "So, what do these Darwinists think? The code just wrote itself?" And then he paused for dramatic effect and said, "Not at Microsoft. It doesn't work that way." Okay? And so people who are aware of these systems for conveying information digitally or alphabetically have long been aware that there's a big mathematical problem with the idea that random changes can generate new information. The problem is there's a reason that the random changes tend to degrade information, and that is that there's a lot more ways to arrange characters in any system of any combinatorial system for conveying information. There's a lot more ways, a lot more arrangements that will produce gibberish than there are that will produce meaningful text or functional sequences. Just quick illustration. Turns out this is a bizarre thing, but if you take just a 12-letter word in the English language, for every 12-letter word in English that is meaningful, there are 100 trillion combinations of letters that are not meaningful, that you won't find in the dictionary, okay? And this turns out to be a common feature of what are called combinatorial systems, and a combinatorial system is just a system where there's a lot of different ways to arrange things, okay? Now, in the 1960s, there were a group of mathematicians and engineers and computer scientists at MIT who found that at a company picnic one day, at a university picnic with some of their biology colleagues in a conversation, they discovered that they were, as a group, really skeptical about the story the evolutionary biologists were telling about how random mutation and natural selection produced all this new genetic information. It's the mid-60s, people are just starting to appreciate the information-bearing properties of DNA and what it does inside living systems and how important it is to life, and these physics math guys are saying, I don't think this works. And one of them was Murray Eden, a famous guy now. He ended up convening a conference called Mathematical Challenges to Neo-Darwinism. And this is one of the things he said, expressing his skepticism. He says, no currently existing formal language system can tolerate random changes in the symbol sequences which express its sentences or meaning. Meaning is almost invariably destroyed. Now, as I mentioned, there's a mathematical reason for this, and I have a way of illustrating this that gets across the problem of the origin of information, why it's such a big problem for the neo-Darwinian theory of evolution. Here's a familiar combinatorial system. It's called a bike lock, okay? It's got 4 dials, and each dial has 10 digits on it. So how many different ways are there to arrange the characters on the lock? 40, right? 10 plus 10 plus 10. What? Trick question, right? Okay. It's 10 times 10 times 10 times 10. There's 10,000 possibilities, which is why a bike lock works, okay? If you imagine we've got a thief out there outside the school, sees a nice new bicycle that he'd very much like to have, but he encounters an impediment to his avarice, the lock, okay? Question, if he encounters a lock with 4 dials like this, is it more likely that he'll succeed in opening the lock or that he will fail to open the lock? Another trick question. Okay, our intuition is, yeah, fail, because we're thinking he probably isn't going to stay at this very long, right? But it does depend, can you see it does depend on how much time he has? I've made some stupid calculations that show if every 10 seconds you get 1 new combination, it will take you about 15 hours to search more than 5,000. Once you get to 5,001, it becomes more likely than not that you'll succeed than it is that you will fail. So if we grant that our thief has 15 hours, then the answer to the question is, well, yeah, it is more likely that a random search will eventually generate the combination and he'll be able to open the lock, all right? But what if our thief, this is our thief out there, randomly searching, but what if instead of a 4-dial lock, he encounters one like this? Okay. Oh, thank you. That's the random search, and here's now the other lock he encounters. Okay. Now what? What's the situation now? Is it more likely that the thief will generate the information he needs to open the lock in the time available to him? Well, let's give him his whole life. Now, I've made calculations on this as well, and it turns out that if he lives 100 years and does nothing but sample combinations, he's only going to sample about 3% of the total, okay? So this is, first of all, a bad way to spend a life. And secondly, it becomes, can you see that in this case, with all the time available, it's going to be overwhelmingly more likely that he will fail than it is that he will succeed. Which means if you're a betting person and you form a hypothesis about what's the likely outcome of such a random search, the hypothesis that he will succeed is overwhelmingly more likely to be false than true. Can you see that? There's a connection to the truth or falsity of the chance hypothesis. Now, the question that I pose in the book is this. If we think of a gene or a protein as a combinatorial system, remember that picture of the DNA molecule that I had up there and had all the A's, C's, G's, and T's? Well, you can see that there'd be a whole bunch of different ways of combining those A's, C's, G's, and T's. And those are going to correspond to a whole bunch of different ways of combining what are called amino acids, which make up they're the subunits of the proteins that the DNA codes for. So what you're dealing with in biology are actually combinatorial systems. There's lots of different ways to arrange the characters in the DNA, only a very few of which are going to yield a functional protein. And the question is, in the case of life, is it more like the first case where with enough time the thief could conceivably open the lock, where he'd get to a better than 50-50 chance of doing so? Or is it more like the second case with a 10-dial lock? And I simplify here, and there's a lot about this in my book, but here's the situation mathematically. That's the search of our... if we're looking at just one gene with the information for building one new protein, the ratio of the sequences that will produce a functional protein to all the gibberish sequences is about 1 over 10 to the 77th power. This has been experimentally determined for a very short gene and protein sequence. Okay? Now, there's only 10 to the 65th atoms in the entire galaxy. All right, so this is a big space to search, a big haystack looking for one little needle, okay? But it turns out that there's only 10 to the 40th organisms in the entire, we're searching our 10 to the 77 possibilities. It turns out that 3.5 billion years is not nearly enough time to search this effectively, because there's only been 10 to the 40th organisms in the whole history of life on Earth, which means that if every organism in the entire history of life, every time it replicated itself, was generating a new sequence of DNA, you'd still only search 1/10 trillionth of the possibilities. Okay? 1/10 trillionth. Yeah, that's right. Which means it's overwhelmingly more likely that a search for a new gene, that's a new stretch of genetic information, randomly like that, it's overwhelmingly more likely that such a search will fail than it will succeed, which means that the hypothesis that such a search did succeed is overwhelmingly more likely to be false than true. Which means that the neo-Darwinian mechanism is not a plausible means of generating new genetic information. Are people following roughly? Okay, kind of liken this to the 2 bike lock cases. This is like the 10 dial lock. And we're giving the evolutionary process essentially its whole life to look, the whole history of life on Earth. And it's not enough time to search the spaces, and so it's going to be more likely than not. Now, anyone seen this film? I think it was called Dumb and Dumber. It had a comic called Jim Carrey. He's kind of a goofy guy, and he sees across the room a lady that he fancies. And so he goes up to her, and he kind of goes, and he has a pickup line, and he says, what are the odds that a girl like me and a guy like you could get together? And he botches his pickup line right from the beginning because he's actually the guy, you know. And she says, not good. And he says, you mean not good? You mean like 1 in 100? And she says, no, like 1 in a million, buddy. And you remember how he reacts if you saw this stupid film? He starts jumping up and down. He says, oh, so there's a chance. There's a chance. Okay? And I sometimes think this is how our Darwinist friends reason. Okay? Just because there's a finite probability of something having happened doesn't mean it happened that way. What you need to know is how many opportunities were there for that thing to happen, so you can make an assessment of the kind I just made to determine whether the chance hypothesis is more likely to have been false than true. What I've just shown is that the chance hypothesis for the origin of information is more likely to be false than true, which means it's a bad hypothesis, and in science we want to infer to the best explanation, and if something's overwhelmingly more likely to be false than true, we're going to be most likely wanting to reject that, okay, and move on. And that's essentially what's happening in evolutionary biology today. And I tell this story in the book. There are many secular evolutionary biologists today who are now saying neo-Darwinism, the standard textbook theory of evolution, does a good job of explaining small-scale variation. It doesn't do a good job of explaining the big changes in the history of life, the origin of new information, the origin of the new body plans that arise in events like the history of life. And so, in a fuller talk, I would explain all that. We're going to skip ahead to what, for me, is the punchline. Now, many new theories of evolution are now being proposed because of the problem that I've described tonight about the origin of information and other similar problems having to do with the origin of the big body plans as well. It turns out that's even a bigger problem, and I discuss those in the book. So here's a kind of an odd thing going on in the Christian world right now. You have a big push to get Christians to accept Darwinian evolution. It's an idea called evolutionary creation or theistic evolution, and I find it really odd because you have all these leading secular evolutionary biologists in the mainstream of the discipline saying, we need a new theory. And to attest to that in my book, I described 6 or 7 of the new theories. And some of these theories have advantages over old-fashioned neo-Darwinism, but I also found in describing these new theories that they too fail to explain the origin of the information necessary to produce, say, these big Cambrian animals. One theory, for example, I really like is called natural genetic engineering. It's been proposed by a biologist at the University of Chicago named Jim Shapiro. Shapiro shows that a lot of the mutations that evolutionary biologists describe are not random at all. They're being directed towards certain outcomes. He says they're under algorithmic control. There's a kind of pre-programmed adaptive capacity so that when organisms respond to certain kind of stresses, they are capable of responding and generating the production of new genes or proteins as needed. But there's a pre-programmed capacity there. And Shapiro describes these non-random evolutionary processes, but he doesn't attempt to explain where the pre-programming came from. And that's what really interests us, those of us who are proponents of intelligent design. Now, I first got interested in this idea of intelligent design back in the mid-1980s. As Mark mentioned, I worked for an oil company. I was doing digital signal processing. It was an early form of information technology. And I had the chance to meet a scientist named Charles Darwin, who was one of the first pioneers in proposing this idea of intelligent design. He'd written a book called The Mystery of Life's Origin. And he had become fascinated with the same question I've been talking about tonight. Where does the information come from necessary to produce the first cell? Where does it come from to produce the first animals? And he suggested in an epilogue to this very important book that maybe when we're talking about the problem of the origin of information, we're not talking about something that's going to be solved by materialistic evolutionary processes, because what we know from experience is that information comes from a mind. And for him, there was this kind of intuitive connection between mind and information. And he said, maybe what we're looking at is evidence of an intelligent cause. Well, in 1985, I had a chance to get to know Thaxton. He mentored me for about a year before I went off to grad school. And when I went off, I was pretty intrigued with his ideas, but not totally convinced yet. And I had a burning question in my mind, and that was, could this idea that information is pointing to intelligence, could that be formalized as a rigorous scientific hypothesis? Now, ironically, I ended up reading a lot of the works of Charles Darwin to get to the bottom of this question. In part, this is my mentor, Charles Thaxton, and another Charles Darwin, and I was interested in his biological arguments and so forth, but I was also interested in his method of reasoning, because he had pioneered a particular kind of scientific reasoning that was more forensic in style. He was reasoning from effects, all the clues we have in front of us, back to their causes in the ancient past. And it became clear from reading Darwin that there was a special method of scientific reasoning. You couldn't make trilobites reappear in the laboratory. They originated only once. So if you were trying to figure out what caused an event in the remote past to happen, you had to use this more historical style of reasoning that Darwin had pioneered. And scientists and philosophers now call that method the method of multiple competing hypotheses, or sometimes the method of inference to the best explanation. But that raised a really interesting question. What does it mean to be a best explanation? Well, Darwin had a principle, and he got it from his mentor, another Charles Lyell, one of the great geologists of the 19th century. And Charles Lyell's idea was that if you're trying to reconstruct what happened in the remote past, you want to choose that hypothesis. The best hypothesis or explanation is the one that cites a cause that is now in operation. That is, in other words, a cause that's in our uniform and repeated experience is producing the effect in question. And when I came across those words on the title page of his book, causes, by reference to causes now in operation, a light went on for me. And I began to think about the problem of the origin of information. I asked myself a question: what is the cause now in operation that produces digital code? What do we know from our uniform and repeated experience about the origin of digital code? Soon after, I encountered another author who was writing about he was applying the information sciences to analyzing the information in DNA. And he made an offhand comment: the creation of new information is habitually associated, he said, in our uniform and repeated experience, with conscious and rational activity. What do we know from our experience that produces digital information? Well, minds, intelligent agents. And Bill Gates has sort of intimated something like this when he says the DNA is like a computer program, only much more complex than any we've ever devised. I think that's a very interesting statement, because if you think about the implications, they're kind of profound. What do we know generates the software at the Microsoft Corporation? Programmers, right? Intelligent agents. That's what we know from experience. That's the one cause of which we know that generates information. And I thought, that's very significant, because as I thought about it, it's not just the code in software, it's It's any place we encounter information in a digital or alphabetic form, whether it's in a hieroglyphic inscription or a paragraph in a book or a section of code in a radio signal or embedded information in a radio signal. Whenever we find information and we trace it back to its source, we always come to a mind, not a material process. And so I've argued in my 2 books, Darwin's Doubt, which concerns the origin of animals, and let's go back here, and Signature in the Cell, that the origin of information that we see arising in the history of life is best explained by a designing intelligence. And the ironic, somewhat mischievous approach I take is to use Darwin's own method of reasoning to make that case. I come to a different conclusion. Darwin wanted to deny that there was actual evidence of design in nature, but I'm arguing that based on what we now know, in particular what we know about the digital information stored in DNA, and I've really only given you just a little bit of the story, because it turns out in addition to digital code in DNA, we have networks of genes that function like integrated circuits. They're called developmental gene regulatory networks, and you can read about them and what they do in my book. We also know that the information in DNA is only part of the information that's necessary to build a whole animal form, that there's a hierarchically organized information processing system that's kind of like, say, the information that we've got information that is necessary to build a circuit board, more information necessary to build the computer. The computer can be linked into a hierarchy of networks. We organize information in hierarchies, and biological systems are hierarchically organized information processing systems, suggesting again, by the same logic, only one known cause of that kind of thing, and that again is intelligence. So I think the case for intelligent design can be made very powerfully at many levels. Now, in close, some of you may wonder how the argument I've made about intelligent design is the best explanation for the origin of the information needed to build these new animal forms in the Cambrian period, how that argument has been received in the scientific community. The book came out in 2013. It was reviewed initially quite frivolously in a number of sources, but then in the fall of 2013, there was a very serious review in the journal Science, written by the distinguished paleontologist and evolutionary biologist at Berkeley named Charles Marshall. And Marshall wrote a respectful review. He said some nice things about the book, but on the crucial argument, he said he begged to differ. And his claim was this. He says that Meyer argues that I'll paraphrase, but he says, Meyer argues you need all this new information to build the Cambrian animals. He says that's not our current understanding. Our current understanding is that all that you would need to have is these gene regulatory networks, the evolutionary process would need to rewire these networks of genes to control the expression of other genes for building the different parts of the animals. And when I saw that passage in his review, I was actually reading it on my iPhone driving home from a haircut. It wasn't a good thing to do, but I was kind of curious what he was going to say. I just about drove off the road, because this was the best possible critique I thought that I could receive. Not because it was correct, but rather because it revealed the weakness in the position of the other side. A network of genes contains what? Genetic information, and lots of it, okay? And the networks of genes that act on other genes for building the parts of the animals, what do those other genes contain? More information. Rewiring a network of genes requires multiple coordinated changes in code. More information. So to explain the origin of the information necessary to build the Cambrian animals, this leading evolutionary biologist begged the question. He simply pushed the question back and said, well, it's in the information that was there prior to the building of the animals or something, okay? But he didn't explain the origin of information in the first place, how you solve, for example, that combinatorial problem that I was explaining earlier with the bike locks, okay? So I actually think that we're at a place of real impasse in evolutionary theory. The crucial questions are either not being addressed, like the natural genetic engineering, really good description of some really real processes, but it doesn't address the deeper question of where the programming comes from. And Marshall's response is of the same kind. He just pushes the question back. So I think it's a very interesting time, and this is my case for intelligent design, and I thank you for listening very much. Thank you. And I'm happy to take questions on American rules. Yes.
So if you have a question, what we would like to do is, rather than me running around like like an ADD fool, which I do every day in class, just kind of come on up here and you can line up and take questions that way. And also, I do want to welcome those of you who are visiting science teachers and visiting professors as well, especially my friend, Dr. Joe Francis, Chairman of Biology at Masters College. Great to have you here, Joe. So we'll open up for questions now, and like I said, if you have one, just come, get in line, and we'll make it happen.
Questions, comments, objections, all fair game. Okay, yeah.
No, I was wondering what your personal view is where that intelligence comes from. Are you a believer in?
I'm a theist.
Christ?
I believe the intelligent designer is God, and I'm also I'm also a Christian. Yes, right.
Yeah, because I'm originally from a Jewish background, and I came to know the Messiah. But all right, I have one other question for you. Do you believe in the 7-day creation? Because I follow CMI. I'm sure you're familiar with CMI, and I kind of believe in the literal 7 days of creation. And how would you jibe that with the Cambrian
Would it surprise you to hear that this is the first question that I get at almost every lecture?
No.
Okay, let me say a couple things about this, all right? The case for intelligent design is, actually I'm going to go back to your first question about the identity of the designer, all right? I've just given you one little piece of evidence for intelligent design, and if you look at the cosmic timeline, with the teachers this morning, I talked about some of the evidence from cosmology and physics, that we see not only evidence of we see three things that I think that help us get a clear picture of the identity of the designer. Did anyone see the movie Expelled with Richard Dawkins and Ben Stein in the final sequence? And Ben Stein got Richard Dawkins to acknowledge that he had no idea where the first life came from, and there might actually in the DNA be a signature of intelligence, which kind of got my attention because at that point I was finishing up writing Signature in the Cell. But then Dawkins said, but whatever that intelligence is, it must have evolved someplace else in the cosmos by purely undirected processes. And so essentially he was proposing a space alien.
Yeah, Watson and Crick has said that.
Well, not Watson, but Crick has proposed at one point a panspermia idea, that life was seeded here in outer space from some sort of intelligent agent. He got so much flack from that, he then forswore proposing any more theories about the origin of life after that. But anyway, if all we had was the evidence from biology, it would be logically possible to consider two different design hypotheses. One, an immanent intelligence, some sort of agent within the cosmos, and one, a transcendent intelligence that would have the attributes of God beyond the cosmos. But in addition to the biological evidence, we also have evidence from physics, where the physicists have been telling us for 50 years that the basic laws and constants of physics are exquisitely finely tuned to allow for the possibility of life, which is to say the very fabric of the universe, the laws that apply to all entities within the universe are finely tuned, suggesting that you have design built into the fabric of the universe itself. And I think that such design cannot be explained by any entity within the cosmos. Thus, I think on scientific grounds alone, there's a good reason to exclude Dawkins's space alien hypothesis. On the other hand, if you only had the physics evidence, you might say, well, maybe it was a kind of deistic designer who wound the clock up at the beginning and then let things run. But from biology, we see that there's evidence of the designer acting in time and space and history, which is what's characteristic of a theistic God, okay, the kind of God revealed in the Bible. So I think when you add up all the evidence for a definite beginning in the material universe is revealed by cosmology, and evidence for the fine-tuning of the universe from the beginning as revealed by physics, and the evidence of a master programmer for the code of life revealed by biology, I think that all adds up to a very, frankly, theistic picture, which is the kind of thing you'd expect on the basis of Romans 1, okay? All right, that's one thing. Now, on this question of age, we have an official position at Discovery Institute, which is we're neutral, okay? Now, and one of the reasons, well, there's a couple of reasons for that. One is that the debate has become very toxic in the Christian world, okay? There's old Earth people and young Earth people, and it's not toxic for everyone who has a view on this, but there are groups that are really at each other about this, okay? And I believe this is not a primary question either of doctrine or of science and worldview, okay? The most important thing, I think, the most important question is whether or not there is a creator, and secondly, whether or not the scientific evidence reveals that such a being exists, okay? So, and that's what Romans 1 is about, right? So the question of, so I would argue that surely the question of how long ago the creation took place is of secondary or tertiary importance to these other issues. The metaphysical claim that there is a creator maybe is the first important thing. The epistemological claim about whether or not we can know the creator from the things that have been made is the second most important claim, and then how long ago it's the third most, okay? Now, many people think that, well, but it is super important because it's a question of biblical interpretation. And there I will share my view, okay? Not the view of the intelligent design movement, which includes both young Earth and older scientists. I personally have never thought that the Bible teaches a young Earth. And the reason for that has to do with what the actual text says about the days of Genesis. When you get to day 4 in the Genesis account, you have, the text tells us that God either created or caused to appear, depending on the rendering of a Hebrew verb asa, which can mean either created out of nothing or simply caused to appear. Either way, we're told that the sun and the moon are caused to appear or created, and that they are given as markers of the days and the seasons. They're time markers. But already by this point in the Genesis account, we've had 3 days of creation, complete with evening and morning, but with no time markers available to mark time the way we mark time today. So I think a really careful, indeed, yea, verily, literal reading of the text suggests that the days of Genesis are of indeterminate length from a human point of view. And there is a great Bible scholar at Covenant College named Jack Collins. He's a Hebrew philologist or Hebrew scholar. And when he's asked, are the days of Genesis long Hugh Ross days or short Ken Ham days? He always answers and says, neither. They're days of indeterminate length from a human point of view.
What about death?
What's that?
What about death?
There's a big argument to be had here, and I'm not going to have it tonight, okay? No, yeah. Yeah, and this is actually one of the reasons that we tend not to answer the question, because you get into this a little bit, and then people want to make this the main issue, you know? Yeah.
The main issue is what you do with Jesus.
Yeah, well, but I mean, scientifically, there's a big metaphysical issue about what does the science reveal? Does it reveal a naturalistic worldview, or does it point to a naturalistic worldview or a theistic one? And yes, obviously, the main issue is Jesus too. Okay, yeah, but anyway, thank you for asking. That's
Very good.
yeah. You may not clap if you don't like that answer. It's fine. I don't care. Yeah. I would tell you that my personal view, when I look at the evidence, is that I tend to view the universe and the earth as very old, and I think humans are relatively recent. We haven't been on, and I believe in a recent creation of human beings. So I have kind of a hybrid view. My closest colleague in the ID movement is a guy named Paul Nelson, and he's a young earth guy. And we tried to argue about this one time and found that we couldn't actually sustain the energy. We got kind of bored because we're more focused on refuting the materialistic Darwinian thing and arguing for design than trying to figure out the age question. But I understand some people are really into it, and it's fine. Yeah.
And I think it's important to add that you do embrace, as all ID people embrace, as do young Earth, all old Earth people, they do embrace, except for the theistic evolutionists, we do embrace special creation. I think that's one of the big...
Another way I often put this, I think a lot turns on whether there is an actual historical Adam theologically. I don't think a lot turns on the age of rocks. Right. Yeah, thanks.
Thank you. My question really is more for the neo-Darwinists, but I'm curious just your involvement with them. You know, when the lack of transitional forms was acknowledged, they come up with punctuated equilibrium.
Right.
When they find animals with similar traits, even if the genetic level, that are not related, they say convergent evolution.
Right.
So my question is, every time there's a discovery that should falsify evolution, they change the definition of what evolution is. So the way they've set up this theory, it's by definition not falsifiable. So is it a scientific theory? I thought a scientific theory had to be able to be falsified.
I'm going to be a little contrarian here as well, but I get the spirit. I agree with the spirit of the question. There's a fine point in the philosophy of science about how do you define a scientific theory. And it turns out it's super hard to do that. It's something called the demarcation question. And a lot of my work was showing that however you define science, that intelligent design is every bit as much a scientific theory as Darwinian theory is. You can apply different yardsticks. And people choose different yardsticks. And this one you're talking about, falsification, came out of the philosophy of science of a guy named Karl Popper. And there are problems with it because it doesn't capture the comparative nature of scientific testing. It says you can just make predictions, and if the predictions don't come true, if the predictions don't come true, well then you're obligated to reject your theory and say it's false. Okay, but scientists all the time have lots of reasons why they think a prediction might have failed other than their theory being wrong. And sometimes it's an okay thing to think, well, maybe there was a disruption in the conditions under which the experiment was performed, or so. And they call those. They'll come up with auxiliary hypotheses. Well, the theory was right, but this other thing was the problem. And it's a judgment call ultimately as to when you've added too many of those in an implausible way to save a theory. All right. I think a better idea about what constitutes science, a better description of the way science works is this method I call inference to the best explanation, where we're really testing things by comparing explanatory power and predictive power. There's a comparative aspect to this. And so I would be happy to grant that Darwinism is a scientific theory. I just think that we've got a better one. And because it explains the key evidences more consistent, in a way that's more consistent with our knowledge of cause and effect. So I tend not to want to say disqualify things with a definition. I want to show that our theory provides a better explanation in relation to the evidence. But there is this kind of weaseliness about neo-Darwinism. It's constantly reinventing itself to avoid, refutation. So, yeah, thanks.
Hi, my question revolves around the concept of irreducible complexity. And I believe, you can tell me if I'm explaining this correctly, there's a certain number of processes that need to be present in the cell for this cell to continue life. And if one of those processes is eliminated, if that number, I don't know if it's 130, 140, something, I believe. But if one of those processes is eliminated, that cell will die. It doesn't make a difference how many more exist. So, given that, how do secular biologists argue that all of these were present at one time and now we have life, rather than slowly accumulating all these processes at one time and still not being able to have life until you get to 140 or 150 or however many it take?
Yeah, really, you did a nice job explaining this. Okay. The idea of irreducible complexity was first proposed by a biochemist named Michael Behe. I was with him last week in Pennsylvania, where he's from. And Behe highlighted these little tiny miniature machines and circuits that are being discovered inside even the simplest cells. I wish I had the pictures. I shared some of this with the faculty this morning, but one of those little machines is called a bacterial flagellar motor. He made it very famous. It's literally a rotary engine. It has a rotor, a stator, a U-joint, bushings, bearings, a drive shaft, and a little hook-like tail that functions like a propeller. It turns at 100,000 RPM. It's hardwired into a signal transduction circuit and can reverse directions on a quarter of a turn. It allows the bug to chase down the sugar it needs to eat. It's amazing, okay? High tech and low life. Behe argues that systems like this, there are many things the mutation selection mechanism can explain, he said, but things like this it can't explain. Because the whole idea of mutation and selection is that natural selection preserves things that confer a functional advantage. But these machines that have all this one particular machine has about 30 protein parts. And if any one of those parts is missing, the machine doesn't work, and this is what you're alluding to. And this applies at higher levels as well, but when you break it down to these machines and circuits, it really becomes a very tractable engineering problem. And Behe shows that the 29, 28, 27, 26 part version of this motor simply has no function. So the intermediate stages on the way from whatever simple thing it started with to the fully functional motor are simply non-viable, which means they won't be selected, which means that the evolutionary process will terminate in encountering those non-functional combinations of parts. So that means that you can't build the motor or these motors gradually in a step-by-step Darwinian fashion, but that's the mechanism that is allegedly gets rid of the need for the design hypothesis. That unguided, undirected mechanism of mutation and selection explains the appearance, but not the actuality of design, say the Darwinists. So Behe says, look, if there isn't a designer substitute mechanism that explains the appearance of design, and we have a striking appearance of design in these little nanomachines, maybe they really were designed. Hey, there's a concept. Yeah, so that's what, yeah, and you asked how they explain this. What has been proposed is there are some intermediate structures that might show that the complexity is not irreducible. And there is something that's been discovered called a little type 3 secretory system. It's a little syringe that has 10 parts, and it's actually in a fully built flagellum. It's on the inside, and then all the other parts get built around it. And in some bacteria, you find these little syringes operating in isolation. But what the people who want to invoke those as the intermediates on the way to the full system don't tell you is, first of all, that only gets you to 10, 12 parts, and all the intermediate stages are still non-viable. But secondly, when you do an analysis on what are called mutation density studies, they've revealed that the syringes are not older than the fully formed flagellar motors, but they're younger or the same age, suggesting that they are devolutionary breakdown products. They're not ancestral. So Behe's argument, I think, has resisted refutation pretty dramatically. But you don't hear that everywhere. So, yeah, we've got a section on that in a book called Explore Evolution.
And you'll be glad to know that the very first day of biology class, the term irreducible complexity is taught. And it's not taught in a dogmatic way and the cell is irreducibly complex. But the idea of irreducible complexity is taught here, and then the students are told, now you look and you see throughout the year if you find things in the cell, if you find things within living systems that you think are irreducibly complex, and be able to tell me and tell your classmates why you think it's irreducibly complex. You can guess the conclusions they reach. Yes.
These kinds of things are actually, there's all kinds of systems that have this property in biological systems. Engineers might think of it as something like functional integration of parts. Yeah,
yeah my question is kind of an emerging question of apologetics, methodology, and also this idea of presupposition. As we're talking about this issue of irreducible complexity, it is very interesting because it comes down, my understanding, to an issue of presupposition. Because the evolutionary biologist is presupposing, like you said earlier, no deleterious mutations, only good mutations resulting with enough time in some machine that you can build sequentially, which is really a presupposition that they presuppose that, first of all, it's not going to get destroyed along the way, second of all, there's enough time to do it. So my question then, as you think about presuppositions and the need for information, and you're looking for a better model that has information given, that is a designer, what about including in your apologetic, and maybe you do, other arguments of that nature of presupposition? The question of not only where do we get information from, what's a better explanation for information, but also what's a better explanation for certain laws of logic, certain laws of science. This is a transcendental argument that Bonson talks about in the presuppositional apologetics. So do you incorporate this argument for a need for a giver of moral law, a giver of logic, the very things that philosophy begs for, but then also, yeah, information, that sort of relates to that too, isn't that kind of all the same?
I'm a big fan of both the moral argument and the epistemological argument for God's existence, the argument from epistemological necessity. It was the first thing that, it probably had the biggest effect on me intellectually in my conversion to theism, and it was, I first encountered it in one of Francis Schaeffer's little books called He Is There and Not Silent. I had a professor who was a Kantian specialist who used to soup up Schaeffer's arguments and give them a bit more analytical, philosophical rigor, but they're pretty good arguments. I've written one essay about that. I'll probably incorporate that into some future work. I think there's an evidential case for God from cosmology, from physics, from biology. I also think these presuppositional arguments have a lot of force, so I'm a both and, not an either-or guy on the approach to theistic argumentation. I also think, oddly, there's a common logical structure. There's inference to when I was studying Darwin, the structure of Darwin's argument in The Origin of Species, I thought, I've seen this before someplace. It was, and I realized, oh, it was in Schaeffer's presuppositional argument for theism. It's the same structure. It's just what's different is the starting point. You either can infer from the evidence to the best explanation, which is the scientific approach, or the presuppositional apologetic approach is to posit something as a possible explanation and then compare the competing explanations to show that your explanation provides the most coherent account of reality. And so it's really it's the same logical structure. Neither of them are deductive, strictly speaking, but it's iterative. It depends on whether you start with the evidence or start with the explanatory supposition. So I think the dichotomy between evidential and presuppositional apologetics is ultimately a false one, and that's been another one of these fights in the Christian world that's been completely unnecessary.
That's a good point.
Yeah.
I'm a both-and person
Yeah.
too. I think, and I'll just pass the mic over because I'm sure there's others. But I think it's interesting that the atheistic evolutionist, is doing that all the time because they're basically saying they're unwilling to allow for the possibility of a God. That's why they define it as naturalistic. It has
Well,
to be.
there's a huge question about the reliability of human reasoning. The human mind itself, this is what Plantinga's work is about, his great books, Warrant and Proper Function, and this has been the main thread in philosophy of science and epistemology since the Enlightenment. On what basis do we justify the reliability of the human mind? The question never occurred to the early founders of modern science because they believed that nature was intelligible because it had been made by a rational God, the very same rational God who had made our minds. So our minds were attuned to the reason that was built into the world. We could perceive it and understand it. But since the Enlightenment, that confidence, once you got rid of God, it became a lot more difficult to justify science, to justify the reliability of the mind and our ability to make sense of the order and design that's built into the world. So it's a big question, but I'm very sympathetic to the concerns you're raising. Maybe we should take one more. I don't want to impose on people's patience. It's getting somewhat late. Yeah.
I guess my question kind of follows along with this last gentleman's here. I just wanted to go just from the most bottom line and understanding of this. So the crossroads between science and faith, and it has to do with presuppositions. Given all the amazing examples that you gave and the tremendous amount of evidence that's out there from cosmology to geology to the DNA to mathematics, physics, there's so much incredible evidence out there now to point to intelligent design. And yet in the face of that overwhelming evidence, which you've eloquently presented tonight, you still, in the general scientific community, they're just trying to come up with new post-Darwinian theories to explain that all away. Doesn't that all boil down to the presupposition, the starting point from a point of philosophy or faith or morality, that their starting point is that for reasons of sin and rebellion, that they don't want to have a God at all. And so they have to come up with all these other kinds of explanations.
I'm tracking with you all the way to the very end. I'm real reluctant to impute motive, okay, about sin and rebellion and that sort of stuff. But what I think we can say is that it does derive from a philosophical presupposition that we must explain everything by reference to purely materialistic causes, okay? And there's a principle of reasoning that people say is definitional in science. The judge in the Dover case affirmed it. And it's the idea of methodological naturalism. Okay, that if we're going to be scientists, we've got to explain everything by reference to naturalistic or materialistic causes. But the problem is, information is not that kind of a beast. If you walk into the British Museum and you look at the Rosetta Stone, you don't say, gee, isn't it wonderful what wind and erosion did? You know from experience that a mind is involved, right? There's more, in other words, there's more to reality than is acknowledged by what's the thing about Horatio and, there's more to reality than is acknowledged by the materialistic philosophy. And so part of what we're doing in the ID movement is not only challenging the scientific interpretation of the evidence, but we're challenging the rules that limit people from considering an interpretation that goes beyond a purely materialistic worldview. So I think you're exactly right on that. That is the key hidden persuader. Yeah, thank you. Great question.
And be patient. It took 200 years for spontaneous generation to finally get blown out of the water, and it's happening. It's happening.
No, there's a lot of movement. I had a very encouraging email today from a really high-powered professor at an amazing place, and not everyone who's friendly to this can be open about being friendly to it, but people, a lot of, I mean, just as there are a lot of people in the field of evolutionary biology who know that the textbook theory is in trouble, there are a lot of people in other disciplines that are sympathetic to what we're doing on intelligent design, and we're starting to feel the cracks. And you know, sometimes you push on a wall and you push and you push and you push, and you think nothing's ever going to change, and then suddenly it just goes. And the young scientists that are being attracted to this, some of the older people who are in established positions, who are friendly, it's some days it's kind of encouraging. So I think we should be very encouraged. People, the truth will win out. It just does sometimes take time.
Let's thank Dr. Meyer again.
Thank you.